Okay, sir. We will live in 20 seconds. So what's that? Leave it.
Hello guys, we're going to do a session for CAT 2019. We've tried something different. We're not doing questions that are exactly at CAT level. We're shooting for questions that are maybe slightly tougher or slightly different. Essentially, when you're looking at questions, you need to kind of open up your mind to say, okay, maybe I could have thought about this different. Maybe I can think of this idea differently. And so we want to plant as many of those different ideas as possible. Because in an exam context, picking open a different approach is going to be dramatically useful, and it saves you a lot of time. And you'll think of different approaches only when you have a stab at it. So a bunch of these questions, almost all of these questions have appeared at in different Olympiads. Almost all of them have appeared in Indian Olympiads, and so they're high quality questions, and they are wonderful questions to say, okay, how do I use this question to think about this idea, so that I can think about structuring questions like this differently. Right? So this can be taken as a test. And so remember that this can be taken as a test on online.im.com. So you can go there, take it as a test, and then follow this up. So it can be taken as a test free. There's no payment for it. So you can go there, sign up, and see. I'm just going to outline that process. Think about how that works. Right? So you go to Chrome, you just press online.im.com. Click on sign up and start learning now, and then enter this process. Say, suppose you say Ramchandar 23@gmail.com, and put any password that you choose. Then you sign up and go in. Once you go in, you're going to have an interface like this. I've set this up so that I don't want to waste the time on actual sign up process. Click on offered courses. This test sits right here. Got a wonderful UI thanks to our tech provider. Hand tip to them. Click on enroll for free, and you're in. When you click here, it opens up to a fabulous testing interface. I'm going to say take test. Bang, we're there. We can take this test. What is the domain of modulus of x plus 1 plus 2 times modulus of x minus 2 less than 6? Now the domain, it's a range of values for which this works. It's solving that inequality, not the domain. Right? So then we click and go next. N cube plus 100 is a multiple of n plus 10. What is the maximum value of n? And so find the sum of the coordinates of C. What is the largest 2-digit prime factor? This is number, what value of n will this be a multiple of 289? What is the unit digit of this? Etc. 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 Find about 9 questions, if I'm not mistaken, in this platform. And then you can take each of those questions. You can move to question number 1 and say, okay, I think this will be the answer. I don't know the answer. I'm just going to randomly click and then see how it works. So you can click at any answer and then go to the next one. The moment you click the answer, you get a dashboard changes here. So you can write down some answer and then say save and next. Very much similar to the kind of UI you can expect to see in the CAT. The aesthetics are different, but the template is same. And so it's a wonderful platform and a bunch of stuff, enormous amounts of content available for free. And so there's a gigantic question bank that is free in different sections on our website. Beyond that, there's a mock that is free. There are 3-4 classes that are free. So vast sections are free, and you can navigate and see what you can get from there. Right? What I'm going to do is I'm going to say, let's take this. I'm going to outline the starting steps, at least the starting steps that I have in mind that you can use for these. Right? So this is not the domain of this function. We're not saying the domain. Pardon my the language. What values of x does this inequality hold? To solve for this inequality effectively. That's what we're trying to do. So there's a conventional way of doing it. Fine. So this, you can say x less than minus 1 greater than minus 1 is the turning point. X around 2 greater than 2 less than 2, that's a turning point. I don't want to do it by this method. And so I'm going to give you the starting step. There are 2 points on the number line, m and n. The distance between these 2 points is modulus of m minus n or modulus of n minus m. There's a fabulous template, idea, way of thinking that can carve open a bunch of questions. So I want you to think along these lines for this question. So we're going to explore that. I'm going to jump across and go to the next question and see if we can have a good starting point. This question is a favorite of mine. It's a fabulous question. We're using the idea that a cube plus b cube can be written as a plus b into a square minus ab plus b square. You might say, where did this come from? How are we going to use this here? But you can use this here. Second idea we use, if you have a number n that divides k, if n divides k and n divides p, then n divides k minus p. A number divides two numbers, it divides the difference of those two numbers. A very simple idea. N divides k, n is a factor of k, n is a factor of p, n will be a factor of k minus p. And we're going to use these ideas for this question. ABCD is a square such that A lies in the positive x-axis. It's a beautiful question where you have to think in terms of the coordinate axis. A sits here, B sits here, and then we have a square. So draw the square, reimagine the square, find the point, and then do this. Do not do this algebraically. We're conditioned to doing coordinate geometry algebraically, thinking in terms of x's, 2x plus 5y and 6x plus 7y. Doing coordinate geometry visually is a compelling method for a bunch of questions. Visualize this and then think in terms of geometry and the visual thing, and then you're through. What is the largest two-digit prime factor of 200C100? Imagine some two-digit prime number. Think in terms of how it will sit in 200 factorial and how it will sit in 100 factorial. I'm not going to give anything more than that. 200C100. You can imagine this as 200 factorial by 100 factorial into 100 factorial. Or you can imagine this as 101 into 102 into 103 all the way till 199 into 200 divided by 1 into 2 into 3 into 4 all the way till 100. One of these two ways of imagining, and then think about which prime numbers will get cancelled, which ones will not, etc. It's a beautiful question. Just bear in mind, just think about the fact, keep in mind the fact that this is 17 square. Our question has got something to do with 17. What is the unit digit of this? I'm not giving away anything. Right? So again, this is an interesting question, so I'm not going to say much about this. I'm going to solve it slightly differently. This again is a beautiful question. Read this, give it a go. Those of you who are trying this just as part of the live video, you'll probably have to pause this and hit one more version of the live video on some other screen and then look at each question and try to solve them. That is probably one approach. Or open the online.2im.com website, try these as a test so that you can see the question and then attempt it and then see what your score is, how your performance is, and the rest of it. And then you can see the solutions down here. Right? I'm not giving too much away for this. Good question. A rhombus has half the area of the square with the same perimeter. Find the ratio of the length of the diagonals of the rhombus. Right? So, two things. There is some trigonometry used here. Right? So, it makes life easier. We know that area of a rhombus is half into product of the diagonals. But there are multiple other ways of thinking about area of the rhombus. Pick one of those. Not necessarily this. This is a routine question, so nothing bhayankar difficult here. Three sides of a triangle, right angle triangle. So we're going to use the idea that sum of any two sides is greater than the third side, and then Pythagoras theorem in some form. That's it, nothing more than that. Wonderful, we're done with that. So I'm going to just cancel that, restart that, and then go ahead and try to solve this. Fine. So this question is written down incorrectly. What is the domain of, we're not talking about domain, we're saying solve for this inequality. Right. The way we have designed this, I'm going to do this very differently. I'm going to think in terms of the number line. X plus 1, we're going to deal with the number minus 1. X minus 2, so we're dealing with 2. Now, what we are saying here, if any point X here, then this distance is modulus of X minus 2. This distance is modulus of X plus 1. X could be here, X could be here, doesn't matter. Fine, so this distance is modulus of X minus 2. This distance is modulus of X plus 1. Fine, wonderful. So now I'm going to imagine X to the right of 2, to the left of -1, and in between. Fine. Easiest is to imagine it in between. So let's imagine it in between, somewhere here. So this distance into 2 plus this distance is what we're trying to compute. This entire distance from -1 to 2 is 3 units. So if this is 1, this is going to be 2. If this is 2, this is going to be 1. So if this is 1, 2 into 1 plus 2, that is 4. That works. But if anything less than 1, that works. Because I'm multiplying by 2, the shorter distance is going to become smaller. The entire distance is 3. So even if I put x here, 2 times modulus of x minus 2 is equal to 6. And so anything to the right of -1 will work. Right? -1 will not work, but anything to the right of -1 will work. Up to just to the right of -1 will work. Till 2 it will work. I'm basically pushing x from 2 to -1. My expression will keep going higher and higher. The larger distance will get multiplied by 2 if I go from here to here. If it works just to the right of -1, it works everywhere. Straight away I know -1 to 2 works. The entire range works. Right? I also know to the left of -1 it won't work, because modulus of x minus 2, that alone is more than 3. So twice of that is more than 6. The other modulus will also be a positive number. So less than -1, I don't need to worry. -1, it doesn't work. -1 to 2, it works. Now let's go to the right of 2. I'm going to draw this diagram again. We have -1 here, 2 here. I'm going to imagine x here, this distance, and this distance. We're going to add twice of this and 1 unit of this. I'm going to break the top distance into -1 to 2 and then 2 and beyond. Let's say this distance is y. This will also be y. So my distance is 3 units plus 3y. 3 units plus 3y is less than 6, or y is less than 1. This distance should be less than 1, or I cannot go beyond 3, or the range that works for me is -1 to 3. Done. Obviously, it goes without saying that the conventional method will work. Fine. But I want to plant the idea of thinking about the modulus of m minus n as the distance between m and n on the number line. A very simple idea, very powerful idea, very crucial idea. So think that this modulus of x plus 1 is the distance between x and -1 on the number line. Modulus of x minus 2 is the distance between x and 2 on the number line. Then we are through. We can just intuitively solve this question without any algebra. N cube plus 100 is a multiple of n plus 10. And so, wonderful question. See, n plus 10, a plus b is a factor of a cube plus b cube. N plus 10 is a factor of n cube plus 1000. N plus 10 is also a factor of n cube plus 100. This we know from algebra. This we know from the question. Wonderful. So far, so good. When we know that n plus 10 is definitely a factor of n cube plus 1000, we know n plus 10 is a factor of n cube plus 100 because the question is telling us that. Put these two together, we get n plus 10 is a factor of 900. This minus this. That's all we need to know. What is the maximum value of n? We know n plus 10 is a factor of 900. Factors of 900, 1, 2, 3, 4, 5, 6, 9, 10, etc., etc., etc. But we're not looking to list all these factors. We want to find the maximum value of n. The largest factor of 900 is 900. If you put n plus 10 equals 900, n is 890. Done. N cannot be more than 890. 890 works. 890 cube plus 100 is a multiple of 890 plus 10. And anything more than that won't work. We are done. It's a beautiful question because there's a very wonderful answer for this. The two things that we need to remember: a plus b is a factor of a cube plus b cube. A plus b will be a factor of a power 5 plus b power 5, a power 7 plus b power 7. A power any odd number plus b power the same odd number will be a multiple of a plus b. That idea gets used in multiple instances. If we're just plugging it in, then we are home and dry. Second, it's a wonderful, wonderful question. So I'm going to draw the coordinate axis, because anytime you're given a point on the positive y-axis, point on the positive x-axis, and that's brilliant. Then you can imagine this, you can visualize this, you can see the diagram. Fine. So I'm going to try to see that. So let's draw this. A lies on the positive x-axis, and A sits on the positive x-axis somewhere. So let's see how it can be here. Let's say this is a point A. B lies on the positive x-axis. Let's say this is B. Point D is 12, 17. Wonderful. This is 12, 17. Wonderful. So point D sits in the first quadrant somewhere. You have to have A, B, C, D like this. It's not a diagram going below. So wonderful. So let's draw AB. So it has to be like this. It has to be like this. It has to be like this. This is a square. This is C. This is D. Fine. Absolutely wonderful question. This is 12, 17. We can say this is H, 0, 0, K. And then we can simplify this. That means this is H, this is K. Fine. So this is a square. Fine. So wonderful question. We need to find coordinates of C. Some of the coordinates of point C. Some of abscissa and ordinate. So we need to find what this corresponds to. Fine. So this is more than H. That is probably more than K. But how much more? We don't know. Fine. So think about this. This point is K. So we need to find this. Right? We need to find coordinates of this point. So we need to find this. Think about this. ABCD is a square. And I'm given away everything with this diagram. And so I'm trying to see if I can push and prod you to a point very close to the answer by constructing the right diagram. And so think about this. The square is a fabulous symmetric figure. The square is placed inside something. That means if this is H, this has to be H. This has to be H. This is K. This is K. This is H. We're done. We're home and dry. K is 12. H plus K is 17. Or H is 5. And so, 12, 17. K is 12. H plus K is 17. Some of these two 17. H is 5. And we're practically done. This point C is H plus K, 17, H, 5. Done. Sum of abscissa and ordinate, 17 plus 5, which is 22. The squares, equilateral triangles, circles, they're wonderfully symmetric figures. So you can do a lot with a diagram. You can do a lot of simplification without resorting to algebra. So be completely on top of the very symmetric figures. Find regular hexagon, regular octagon, square, equilateral triangle, circle. Draw these diagrams and try to get everything in terms of something, some one variable that you know. Area, perimeter, interior, circumradius, the whole shebang. If you do that, you'll get very comfortable with these symmetric shapes. In this case, we don't need to do, you don't need to resort to Pythagoras theorem, distance formula, this, that, nothing. We're practically just looking at the diagram and you can find the coordinates of C. What is the largest two-digit prime factor of 200 C100? So think about this. This is 200 factorial by 100 factorial into 100 factorial. Largest two-digit prime number is 97. I'm going to think about whether 97 will divide this. Right, so there is definitely a 97 in this number. And if there are 97 here also, There's a 97 here also. In 200, we have a 97 and a 194. In 100 factorial, we have a 97. Here we have a 97. The 297 sitting in this number are going to get knocked off with the 297 sitting in this number. So the 2-digit prime number, that is 97, appears in the numerator, but it gets cancelled with the 2 times it appears in the denominator. So it doesn't work. And so the next number is 89. So 89 appears here, 89 appears here, and it appears here. 89 will appear here twice, it will get knocked off. We cannot have 89 in the number. Any 2-digit prime number will appear here, and it will appear here. It will appear here probably twice, so it's going to get knocked off. So when will it be retained? It will be retained when it appears thrice in 200 factorial. Bam, we are done. So 89, 83, 79 will all appear only twice. 200 divided by 3 is 66 point something. Even 67, which is prime, will appear only twice, in 67 and in 134. The third 67 is not available. Right? So 67 doesn't work. So prime number less than 67. 65 doesn't work, 63 doesn't work, 61. 61, 122, 183. All three will have 61s in them. We're advertising our own event. All three will have 61s in them. 2 of those 61s will get cancelled. This is 61 in 100 factorial, 61 in 100 factorial. They'll get knocked off, and we'll still have a 61 in it. The largest 2-digit prime factor of 200 300 is 61. These kind of questions we can very well expect in the exam. It's a beautiful question. It doesn't require anything conceptually. It doesn't require anything computationally. It requires a little bit of common sense and understanding of what factorial actually means. Once you know that, you're done with home and dry. It's a wonderful question. It's a wonderfully tough question. So give it a go. I'm going to give you some time to poke around with this, and then we'll solve this. And so you're saying, what is the integer value of n for which n square minus 3n minus 19 is a multiple of 289? N square minus 3n minus 19 is a multiple of 289. I want to say, how do we do this? N square minus 3n plus k or minus k, we might be able to factorize this. N square minus 3n minus 19 is not factorizable, and that's tricky. There's no value there. But n square minus 3n plus something else could be factorizable. Minus 3 can be written as 5 minus 2, or minus 5 plus 2. Minus 5 into 2 is minus 10. So n square minus 3n minus 10 can be factorized. Splitting this minus 3 as minus 5 and plus 2. We can split as minus 6 and plus 3, minus 7 and plus 4, minus 8 and plus 5, minus 9 and plus 6, minus 10 and plus 7, minus 11 and plus 8. Or n square minus 3n minus 10 is factorizable. N square minus 3n minus 18 is factorizable. Minus 19 is not factorizable, minus 18 is factorizable. Okay. This number is n square minus 3n minus 19 plus 9. N square minus 3n minus 19 plus 1. N square minus 3n minus 28, which is n square minus 3n minus 19 minus 9. Right, so think about these numbers. This is minus 40. So to minus 19 we are subtracting 21. This is minus 54. We are subtracting 35. Minus 70. We are subtracting 51. Minus 88. We are subtracting 69. think about this, there's something special about these numbers, something that can just carve this open completely. You can factorize this and write it as a sum of something else, then you're through. And remember, 289 is 17 square. You've got to find a 17 somewhere. It's a beautiful question because the answer sits in this factorization. N square minus 3n minus 19 can be written as n square minus 3n minus 70 plus 51, or minus 19 minus 51 gets us to this point. Right? This number is n minus 10 into n plus 7 plus 51. If you're getting there, it's a wonderful, wonderful factorization. I'm going to go to the next page. N minus 10 into n plus 7 plus 51 is a multiple of 289. Say it's a multiple of 17. This is a multiple of 17, or n minus 10 into n plus 7 is a multiple of 17. This is a multiple of 17. What does this tell us? This number plus 17 is this number. So if this is a multiple of 17, this is also a multiple of 17. Both can be multiples of 17, or both will not be multiples of 17. We cannot have a scenario where one is a multiple of 17 and the other is not. So if this product is a multiple of 17, this is 17k, this is 17l. Both are multiples of 17, or both multiplied is a multiple of 289. So the only way this is possible is if this is a multiple of 17, in which case this number will be a multiple of 289 plus 51. That means we can write this number as a multiple of 289 plus 51. It's either not at all a multiple of 17, or it's a multiple of 289 plus 51. 289 plus 51, 289, a multiple of 289 plus 51 cannot be a multiple of 289. 289k plus 51 is definitely not a multiple of 289. Or what is the integer value of n for which this works? There is no integer value of n for which this works. There's no answers possible, 0 possible values. It's a wonderful, wonderful, wonderful question. The idea here is n square minus 3n minus 19. We look to factorize this and then find an adjustment term. Break it into a product of two expressions, plus number or minus a number. Just like the idea or technique of completion of squares, we're looking to break this open in some form. And that's the kind of idea which is very useful to try to get comfortable with algebra, you get comfortable with manipulating, you get comfortable with doing the approach on completion of squares. That becomes very simple. So we want to do these kind of questions purely to say, okay, these are not going to come in CAT. This is probably a question where they say, prove there is no value of n, where n square minus 3n minus 19 is a multiple of 289. When you're thinking about it very differently, you want to come upon this method. But thinking along those lines helps us broaden the horizon on how to factorize something, how to manipulate a quadratic expression. We know one way of manipulating is completion of squares. Another way of manipulating is factorizing it and then having an adjusting term. Both useful. What is the units digit of 1 power 5 plus 2 power 5 plus 3 power 5 all the way till 100 power 5? Fine. So this is fabulous, fabulous question because it's based on a very simple idea. A power 5 plus B power 5 is a multiple of A plus B. Why am I saying this? 1 power 5 plus 99 power 5 is a multiple of 100. 2 power 5 plus 99 power 5, 98 power 5 is a multiple of 100. 3 power 5 plus 97 power 5 is a multiple of 100. So if we pair up 1 and 99, 2 and 98, 3 and 97, all the way till 49 and 51, everything will be a multiple of 100. So this expression is a multiple of 100 plus 50 power 5 plus 100 power 5. This is a multiple of 100, this is a multiple of 100, this is a multiple of 100. unit digit is 0, even the 10th digit will be 0. Based on the idea that a power odd power plus b power odd power will always be a multiple of a plus b. Nothing more than that. The methodical brute force way will help, will take you to the answer. Probably going to take slightly longer to do it. And it's always fun to think of a number a power 5 plus b power 5 as a multiple of a plus b and then tweak from there on. This is a fabulous question. So it is going to take time to solve this. So take that time and we'll get this. Find the sum of the elements of a finite sequence of 16 numbers such that it reads the same from left to right. The sum of any 7 consecutive terms is minus 1. The sum of any 11 consecutive terms is plus 1. I'm going to write this expression down. So this is A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, A13, A14, A15, A16. It reads the same from left to right. That means A1 is equal to A16, A2 is equal to A15, and so on. So we're going to use that approach. So keep that in mind. The sum of any 7 consecutive terms is minus 1. So think about this. A1 to A7, if we add, that will be minus 1. A2 to A8, if we add, that will be minus 1. Now think about this. From A1 to A7 and A2 to A8, what is the difference? The first one has A1 and 6 other terms. The second one has 6 same terms and A8. What does this leave us with? This basically tells us A1 and A8 should be same. A8 will be equal to A9 because it's symmetric from left to right. So A1, A8, A9, A16 are all same. Same idea for the second thing. The sum of 11 consecutive terms is 1. So A1 to A11 and A2 to A12 are same. That means A1 is equal to A12. A1 equal to A8. A1 is equal to A12. A1 equal to A16. A8 equal to A9. So bunch of things are equal. So let's go back and simplify this. I'm going to use the same idea. A1, A2, A3, A4. A1 I'm going to call it as A. Right, A8, A9, A16. This is A. This is A. This is A. 10, 11. A12 is A. If A12 is A, then A5 should be A. A6, A7, A8, A9, A10, A11, 6 terms, plus A5 or plus A12, both are same. So A5 is A. A8 and 7th term from there, A15 should be A. That means A2 symmetric should be A. Right. A2 and then the 12th term, 11th term from there, A2 plus 11 is A13. A1 makes A12 equal. A2 will make A13 equal. This is also A. So from the right, first, second, third is out. 4th, 5th terms are equal. So A4 should also be A. Right, so A1, A2 are A. A4, A5 are A. A9, A8, A9 are A. A12, A13 are A. A15, A16 are A. Right? Let's say A3 is B. And A10 will be B. A3 plus 11, A14 will be B. And so A3 plus 7, A10 is B. A9 and A8 are equal. A10 and A7 should be equal. A7 should also be B. Fine. We're missing A6 this side. And so A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, 12, 13, 14, 15, 16. A11 and A6 we are missing. A11 should be same as A4. A4 is A. A11 should be A. A6 and A11 should be same. This is also A. So our sequence is AA, B, triple A, B, double A, B, triple A, B, double A. It has only A's and B's sitting inside. Only two numerical values, but in this sequence. So now what do? Very simple. Sum of any 7 consecutive terms. That is this 7. 1, 2, 3, 4, 5, 6, 7. So it is 5A plus 2B is minus 1. 11 consecutive terms. To this we are adding this. 6A, 7A, 8A plus 3B. 8A plus 3B is 1. So let's write this down. Oops. 5A plus 2B is minus 1. 8A plus 3B is 1. With this, we solve for this, we'll get A and B. I'm going to multiply this by 3. So we get 15A plus 6B is minus 3. Multiply this by 2. 16A plus 6B is 2. Subtract 1 from the other, we get A is 5. 5 into 5, 25. 25 plus 2B is minus 1. 2B is minus 26. B is minus 13. Or our expression is 5, 5 minus 13, 5, 5, 5 minus 13, and so on. We want to find sum of the elements. So how many B's are there? 1, 2, 3, 4. So we have 9A plus 4B in the system. 9 into 5 is 16 numbers totally. 12A and 4B in the system. 12 into 5 is 60. Plus 4 into B is minus 52, which is 8. And wonderful question. Not easy, but not very difficult either. It's more like a logically constructing a puzzle. It is symmetric. So A1 is equal to A16, A2 equal to A15. Sum of any 7 consecutive terms is minus 1. So every 7th term is equal. Every 11th term is equal. So A1 should be equal to A8, A1 should be equal to A12, A1 should be equal to A16. And then we make all the A's and all the B's. So we effectively boil down to only A's and B's in this entire sequence. 2 equations, 2 variables, we are done. A rhombus has half the area of the square with the same perimeter. Find the ratio of the length of the diagonals of the rhombus. So the wonderful question. Ratio of the lengths of the diagonals. So there's a rhombus and there is a square. Side A, area is A square. So area of this is half A square. We know area is half into product of the diagonals. I don't want to do that. If I go down that route, then I'm going to end up having to find the diagonal length in some form and then simplify that, which is incredibly tough. I'm going to use the idea that area of a triangle equals half BC sin A. Half into product of 2 sides into angle between the 2 sides. So if say this angle is theta, then area of this triangle is half A square sin theta. Area of this triangle is also half A square sin theta. Total area of the rhombus is half A square sin theta into 2, which is given to be half of A square, or sin theta equals 1 by 2. This means the angle is either 30 or 150, or we are through. This is 30, this is 150, This is 30, this is 150. So if you have, we effectively have a rhombus where the angles, I'm going to just set the pointer right, the angles are 30 and 150. So it's a rhombus. We want to find the ratio of the diagonals. So this is 75 degrees, this is 15 degrees, this is 90. So you want to find ratio of the diagonals. Ratio of the diagonals is nothing but tan 75 or tan 15, depending on how the question is saying that. So if you know some trigonometry, then you can simplify this. This is tan 30 plus tan 45 by 1 minus tan 30 tan 45. We don't need to know trigonometry for this. Remember, we are not solving just scat level questions. We're saying we will look to go over and beyond that. So 1 plus 1 by root 3 by 1 minus 1 by root 3. So this is root 3 plus 1 by root 3 minus 1. For some reason my interface is misbehaving. So root 3 plus 1 by root 3 minus 1, multiply and divide by root 3 plus 1. So this becomes 3 minus 1, which is 2. Root 3 plus 1 whole square is 3 plus 1 plus 2 root 3 by 2, which is 2 plus root 3. Wonderful question. The idea, one of the reasons why I wanted to do this question is not to discuss the tan 75 part or trigonometry or tan A plus tan B, but the idea that area of rhombus is half into product of diagonals, but it need not always be half into product of diagonals. You can imagine rhombus as two triangles and kind of reimagine it as half BC sin A, half A square sin theta into 2. Area of a rhombus is A square sin theta. That's another way of thinking about it. And if we can reimagine it like that, then this question becomes, these kind of questions with rhombus become that little bit simpler. We're on to this question on mensuration again. Wonderful question. So let x be a real number on the sides of a right angle triangle. What could be the area of a triangle? Very straightforward question. If we say sum of two sides greater than the third one, you can say x plus 3 plus 2x plus 5 greater than 3x plus 2. This always holds good. So we say x plus 3 plus 3x plus 2 greater than 2x plus 5. The 5 disappears. 4x greater than 2x or x greater than 0. X is positive. That much we can sense. That means this is greater than this. This is not the hypotenuse. Either this is the hypotenuse or this is the hypotenuse. Right? More than that, the triangle area seems to be integers. So maybe this is 3, 4, 5, 6, 8, 10, something like that. So I'm going to take a chance and see if I can figure it out. X plus 3, 2x plus 5, 3x plus 2. 3, 4, 5 doesn't work. 6, that means x is 3. 2 into 3, 6 plus 5, 11. 3 into 3, 9 plus 2, 11. 6, 8, 10 doesn't work. 5, 12, 13. This could be 5, x plus 3, x is 2. 2 into 2, 4 plus 5, 9. 3 into 2, 6, 6 plus 2, 8. That doesn't work. We'll have to find different combinations that could work. That could be tricky. And I'm thinking in terms of 3, 4, 5, 5, 12, 13. If there are 5, 12, 13, area will be half into 5 into 12, which is half, is 5 into 6, 30, or 10, 24, 26 will have 60 square units. 10, 24, 26, this is 10, x is 7. 2 into 7, 14 plus 5, doesn't work. So maybe we'll have to do it algebraically. And so one of these should be the answer. And so one areas like this. So if one of these works out, we are nice. And so 10, 24, 26 indeed has an answer like this, but that doesn't work. 7, 24, 25, the area won't match with this. 5, 12, 13 will work. 8, 15, 17. Half into 8 into 15, 60, that could work. So 8, 15, 17. So this is 8, x is 5, 2 into 5, 10, plus 5, 15, 3 into 5, 15, plus 2, 17. We have a winner. X equal to 5 gives us 8, 15, 17. The textbook method of doing this, we're going to say x plus 3 whole square plus 2x plus 5 whole square is 3x plus 2 whole square. If this does not fetch us an answer, we're going to do x plus 3 whole square plus 3x plus 2 whole square equals 2x plus 5 whole square. So x square plus 6x plus 9 plus 4x square plus 25 plus 20x equals 9x square plus 4 plus 12x. Bring x square plus 4x square is 5x square, 9x square minus 5x square is 4x square, 12x minus 26x minus 14x, 4 minus 29, 4 minus 34, this is minus 30 equals 0, or 2x square minus 7x minus 15 equals 0. 2x square minus 10x plus 3x minus 15 is 0. 2x into x minus 5 plus 3 into x minus 5 is 0. 2x plus 3 into x minus 5 is 0. X cannot be negative. X equal to 5. We have a winner. 8, 15, 17. Area is half into 8 into 15, which is 60 square units. Right. So the questions which we've discussed today are all kind of possible questions. The level of CAT exam has gone up. The exam is becoming tougher and tougher. But more importantly, these are questions that are solved slightly unconventionally, slightly differently, slightly wackily. The Olympiad questions are always a treat because they're about 60% of them are non-routine, non-regular. You cannot just take and do a simple plain vanilla equation and then get to the answer. That's impossible. And so you will have to carve it open by thinking slightly differently. So why we've done this whole entire session is to say, okay, think of area of a rhombus as a square sine theta. If sum of any 7 consecutive terms is minus 1, every 7th term is equal. A power 5 plus b power 5 is always a multiple of a plus b. Reimagine n square minus 3n minus 19 as n square minus 3n minus 70 plus 51. So 200 factorial. We want a number that appears thrice in 200 and once each in the 200 factorials. That's what we're thinking about. Draw the diagram, and because it's a symmetric figure, you can place the coordinates very easily. A cube plus b cube is always a multiple of a plus b. If some number k divides a and it divides b, then it definitely divides a minus b. That's a takeaway. The distance between any 2 points on the number line p and q is modulus of p minus q or modulus of q minus p. It works both ways. It's a wonderful set of questions. I really enjoyed solving them and picking them and putting them together. We want to do a few more sessions like this where we can say, okay, let's not just do a template question, but let's just do a question where we discuss an approach, where we say, okay, draw the axis, imagine the point for coordinate geometry, draw the number line and simplify this. So reconstructing the way we think about how different question, that is very vital. Right? So remember, those of you who have not taken this as a test, click in, sign up, and have a go and take it as a test because it's wonderful. We're going to look to add a bunch of tests which are slightly different, slightly out there, where your mind opens up in the process of either trying to solve it or trying to find a solution. One of the two. We're going to look to push the envelope in some parts. We're not very sure this is not really just CAT practice, but solving questions like this, especially the rhombus question or the square on the coordinate plane with x-axis, y-axis question, or the n square minus 3n minus 19 question. Those questions are wonderful because they say, okay, we do everything in one normal way, but maybe we should try something else. And if you do try that something else, it falls in place. And the more something else you try in your life, the more receptive you're going to be to new ideas. So that is something that we want to push. Those of you who have not tried the platform, do try up. Signing up takes about 70 seconds. Seeing all the free content is very much useful. There are about 20 hours of freely available content on the 2IIM platform. There are about nearly 1,000 questions on the question bank alone. We've expanded the question bank dramatically and with a lot of effort. There is no question in our question bank which is without solution. A large number of them are available with video solutions, and you don't even require a sign-in to view the question bank. We want it to be the absolute kind of bank guarantee, the place for practicing CAT level questions and without paying anything. So there's lots of things that you can learn after paying in online.2im.com, but there is still a lot which you can just sign up, which you can just go visit the website without even signing up and take value from. So we get lots of emails from students who have tried this, who basically say, look, I could have just not afforded the course, but I love learning from the platform on YouTube. And we love people who reach out to us and tell us that, which is why we've kept the YouTube channel free and the question bank free. And wonderful. Thank you. I'm just going to sign off. If you have any queries, questions, do post them on the chat window or on as comments on YouTube. Best wishes for CAT. We will circle back in say a week or maximum 2 weeks, and then have one more session, something like this. If you have something else in mind for a learning session, do ping us. We will take it up and have a go at it. See you guys. Best wishes. I've been told there's some kind of delay. So who